First question A part, distinguish between periodic and non-periodic signals, and second part is even and odd signals with one example for each. It is asked for 6 marks from Jan February 2021. Okay, so what is asked in your question? You have to distinguish between 4 different types. One is periodic, non-periodic and even and odd signal. So first let us see what is a periodic and non-periodic signal. So periodic, what the meaning is given by its name itself. Periodic means which repeats after a certain instance of time, which keeps repeating. Non-periodic means which does not repeat. Okay, suppose if you have a sinusoidal signal, so 0 to t, again it keeps on repeating 2t, 3t, etc. Then it is called as a periodic signal, where the non-periodic signal is which does not repeat. Okay. So the differences. So first let us see about your periodic and non-periodic signal. Periodic signal is a little bit elaborated. So periodic signal, as I have mentioned, a continuous time signal. So first we will see for a continuous case, and second we will see for your discrete case. Okay. So in the case of continuous time signal x of t is said to be periodic if it satisfies the condition. So this is your condition to be satisfied. X of t is equal to x of t plus capital T for all t, where t is a positive constant, right? So if this is an example, see here it keeps on repeating 0 to t, t to t, 2t, it is again repeating, from 2t to 3t, again it is repeating. So any signal whose amplitude value repeats after certain amount of time is called as a periodic signal. Okay, and this is the one of the example of your periodic signal. Whereas non-periodic signal, you have only one condition. If this does not satisfy the condition, any sequence which is not periodic is called as a non-periodic sequence. Any signal x of t for which there is no value of t to satisfy the equation 1 is called non-periodic signal. The example of your continuous wave signal. And for discrete wave, how will you get x of n is given by, so this is the amplitude. You have 0 amplitude for 2, 3, 4, etc. Okay, so this is called as your discrete non-periodic signal, where A is your amplitude and T1 is your, in this case, A is your amplitude and T1 is your duration of your signal. Okay, so these are the two examples of your periodic signal and non-periodic signal. Now let us pass on to your periodic signal classification. That is the next type, that is called as a discrete periodic signal. Before that, you have the least frequency. The lowest frequency is called as your fundamental frequency. Okay, so the smallest value of t that satisfy the equation 1 is called as the fundamental period of x of t. So in this case 0 to t, so this is called as your fundamental frequency. Okay, fundamental time. Okay, frequency will be equal to 1 by t. Okay, so that is what given here. The smallest value of t that satisfy equation 1 is called as your fundamental period of x of t. The fundamental period t defines the duration of one complete cycle of x of t, right? So it defines one complete cycle. If it is a sinusoidal wave, then one complete cycle. So here it is a triangular wave. It defines one complete cycle of x of t. The reciprocal of the fundamental period t is called as what? Fundamental frequency of the periodic signal x of t. It describes how frequently the periodic signal x of t repeats itself. So what will be your ff will be equal to 1 by t hertz or cycles per second. Okay. Now you have the fundamental frequency, then you are going to find out the angular frequency. Angular frequency is measured in radians per second, and omega will be equal to 2 pi by t, which is equal to 2 pi into f, where 2 pi is the radians of one complete cycle, right? So since 2 pi radians is one complete cycle. Whereas in the case of discrete signal, it is periodic discrete signal. A discrete signal x of n is said to be discrete if it satisfies the condition. First equation, similarly you are going to repeat it in the second condition, the second equation, but it is discrete in nature. So x of, it is not continuous, right? So x of n plus n for all n, where n is a positive integer. So this is the example of your periodic discrete signal. Okay, and what will be your angular frequency? In this case it is omega. Angular, for the discrete case, it is represented by ohm, which is equal to 2 pi by n. Here it is radians per second. So what will be here? Radians per samples. So the condition here is x of n plus mn is equal to x of n, whereas in the case of similar to x of t plus mt, where t will be any integer. Okay, similarly here m is any integer. The fundamental period of x of n is the smallest integer n for which equation 2 holds. Okay, so this is similar to that of your continuous case. Now the next second option is your even and odd signal. So what is the difference between your even and odd signal? A continuous time signal x of t is said to be even signal if it satisfies the condition. So what will be the condition? X of minus t will be equal to x of t for all t. Even signal are symmetric about the vertical axis or the time origin, right? Okay, it is symmetric across your x-axis and y-axis. A discrete time signal x of n is said to be, this is for continuous case. So what will be for your discrete case? X of n is equal to x of t will be replaced by x of n. X of minus n will be equal to x of n for all value of n. So example, this is for continuous case, right? Continuous even signal, it is symmetric for t by 2 minus t by 2. Similarly, x of n, it is symmetric. Odd signal. So what will be your odd signal? X of minus t will be equal to minus x of t. That is the difference. The signal x of t is said to be odd signal if it satisfies the condition x of minus t is equal to minus x of t for all t. Odd signals, is it symmetric? No. Okay, it is asymmetric. So odd signals are asymmetric about the time origin. The discrete signal x of n is odd if instead of t you are replacing it by n. That is the difference. Now what will be the example? Here it is not symmetric, right? Similarly here it is not symmetric. Okay, so these are the two examples. This is for your continuous case, continuous odd signal, and this is for your discrete odd signal. So these are the points which you can write for 6 marks.